Today's session is all about image targets. And we're going to go into some advanced topics related to image targets. We're also going to be addressing a lot of the common questions that I get asked, via email or Slack, people trying to do certain things that might not be super obvious. We're going to dive into the nitty-gritty and talk about how these things work and how you can achieve these types of situations here. So the agenda here for this session, again, lots of different pieces of content. We're going to kind of start at the beginning, go from there. We're not going to be covering the actual image target creation process where you upload the image target to your April project. That's been covered in different live learning sessions, and there's should be pretty straightforward for folks at this point. But the agenda here today is we're going to be talking about different image target types, image target quantities. We're going to dive into the AR engine and the image target event lifecycle and what's happening and when and what you can do when these types of things happen. We're going to spend some time talking about XRExtras because XRExtras, we've built a lot of great components and logic that covers most of what people want to do. It doesn't cover everybody's exact use case, but for 95% or more percent of people, it probably does exactly what they want to do. And XRExtras is great because if it doesn't do exactly what you want to do, well, all the source code is there on our GitHub repository, and you're always welcome to create a copy of a component that you like and import that code into your April project and modify it in some way and get exactly what you want there. We're also going to spend some time talking about parent and child entities and the relationships between, an image target entity and perhaps your video or your 3D model entity. A lot of times people will ask questions about, well, I want it to be shifted or rotated somehow independently of the image target. So using parent and child entity relationships is a great way to achieve those types of effects. How to change active image targets. So you might have a large number of image targets or some logic where you don't know where somebody might be coming into an experience, and you might need to change the active image targets that they're looking for on the fly. And then we'll also talk about implementing your own custom event handlers. In today's demo, I'm going to essentially take one of our components, one of our predefined components, and we'll show you how you can modify it and do some custom things in the event handler. Just one other thing, going back to the creation of image targets, as a friendly reminder, always use the image target simulator. So when you upload your image target, always use the preview tool, because that is the absolute best way to understand in advance how well or how poorly is that image target going to track. It's good to know that before you get too far down the road. Day of launch, I have a very textureless image target that's not a good candidate. You want to identify these things in advance. So with that, let's jump right in. So a couple of basic slides here, and we'll get into more advanced things as gradually as we go. So today we support different types of image targets. We support both flat and curved. So specifically, for curved, it's cylindrical and conical. So flat image targets are great for tracking 2D images like posters, signs, magazines, boxes, billboards, and so on. And then in the curved image target category, we first have cylindrical. So these types of image targets are great for tracking images that are wrapped around cylindrical items like cans or bottles. And here you see an example of a wine bottle here. And then finally, conical. So this would be where you have image targets that are wrapped around objects that have a different top versus bottom circumference, here like a coffee cup. So these are the three types of image targets that we support today. And then of course, on top of that, we also support markerless tracking. We call this world tracking, also known as SLAM tracking, where you can place content on surfaces without markers, and we support face effects as well. Now, I get asked a lot about how many image targets can I have? So there's a couple of different answers to this. The first is you can have an unlimited number of image targets on a per project basis. So, think about maybe I have a comic book that has 100 different pages. I could upload 100 different image targets to my project. Now, while you can have an unlimited number of image targets in the library for your project and available to your project, only a subset of those can be active at any given time. And when I say active, What I mean here is that the WebAR experience is only searching for up to this quantity at any given time. So if you're only using image tracking, you can have up to 10 image targets active at any given point in time. Could be, the first 10 pages of a book, for example. Now, if you're doing both image tracking and SLAM tracking, or world tracking, whatever you want to call it, then you can only have 5 active image targets. Now, you can also specify up to 5 image targets that are what we call auto-loaded, meaning when the WebAR experience begins, those up to 5 image targets will be active and ready to go right off the bat. No need for you to do anything special or different to activate those. And we'll get into this a little bit later in the webinar here today, but we have an API. It's our XR8.XRController.configure API. And this allows you to change the set of active image targets on the fly, whether it's to load the initial set of 10, to change things on the fly. We'll talk about some different use cases where you might want to leverage this API at runtime. Okay, so under the covers, there's a lot of things going on. Basically, what our AR engine is doing is the AR engine is firing events at different places in the image target lifecycle. So we fire, and I've highlighted in red, which are the ones that you probably care about the most, and what probably 99% of people are implementing listeners for to do something when these events take place. But again, the AR engine is firing events at different points in the life cycle. Now, what actually happens in response to these events is completely up to you. And a lot of our pre-built components will do common things like showing or hiding a 3D model, or showing or hiding a video, triggering an animation, perhaps manipulating some type of UI element to tell a user that to rescan the image target if it's lost. If the image target is lost, you might have it, make a UI element visible. So really, at the end of the day, you have complete control and flexibility over what is actually happening here. And for more information, definitely take a look at our documentation. There's a whole section on the events that the engine fires. But at a high level, the events are loading, scanning, found, updated, and lost. And again, the ones in red are the ones that typically people do things with and care about the most. The names of these events can vary slightly based on the framework that you're using. For example, in A-frame, it's XR image found, or XR image updated. In Three.js, you would likely have a pipeline module, and it would be listening for reality.image found. In Play Canvas, it would be XR:image found. So again, the docs have all the specifics on the names of these events, but just be aware that, copying and pasting a little code snippet, if you're looking at, an A-frame example versus the Play Canvas versus Three.js, it's going to probably need a little bit of massaging and tweaking here. So, but again, in 99% of cases, you're probably going to care most about the updated, the found, the updated, and lost events. But let's dive into these a little bit further and explain kind of what's going on here under the covers throughout the lifecycle. So the first is the loading event. So this is emitted when the process of basically like the initialization of the image targets is happening. So when the engine and the end user phone is loading the image targets that are going to be activated. So this event returns a list of the image targets, name, type, metadata. And when these image targets are loaded, what's the end user's phone is actually downloading a small grayscale version of the reference image target that you've uploaded. And the phone is downloading that because with eighth-wall, all of your data and all the processing is safe and secure local on device. All the computer vision algorithms, all of the AR is running local on device in browser. Now, after loading, then you get the scanning event. So this gets emitted once the image targets have loaded and initialized. And at this point, this is where things are ready to start scanning or looking for the image targets in your world. So this, in addition to name, type, and metadata, it also will return the geometry information about the image target, whether it's a flat or a curved. And if it's curved, what are some of the properties of that curved image target, like, radius and things like that. And this is the event that, typically you would in response to this event, you would do things like construct geometry or maybe pop up UI elements telling the user to now like, okay, go ahead and now point your phone at the, the wine bottle or the beer can or the poster or things like that. Okay. So now the three that are probably most familiar to you: found, updated, lost. So the found, or XR image found or XR image found, depending on the platform. This is emitted when a given image target is found for the first time or found again after it's been lost. And this is generally where you would tell your AR content, whether it's the video or the 3D model, to display, make it visible. And align it with the position, rotation, and scale of the image target that's been returned. Then you've got the updated event. This event fired, this is the one that's going to be firing all the time. This is the event that fires anytime there's a change to the position, rotation, or scale of the image as it's seen through your phone. So, if I'm holding a business card in my hand, it'll be initially found. If I move this around in real time, the engine is firing, constant events telling me the new position, rotation, and scale of the image target. And we do this on every update so that you can basically anchor your content to that image target so that your 3D model or your video can also then in turn be updated to follow along with the image target. And then finally, there's a lost event. So the lost event, as you can imagine, it's fired when the target is no longer tracked. So you take it out of view of the phone, the lost event fires. And this is generally where, you would, tell your 3D model or your video asset to maybe set visible equals false. You don't want to display it anymore. But again, that's what most people do. Some people don't want that behavior. And we'll talk about how you can override these things and how you can implement or not implement listeners for certain events to really get the exact behavior that you're looking for here. Okay. Now, another key thing is I always want to bring up XRExtras. You've probably, if you've been developing with 8th Wall, if you've looked at any of our sample projects, if you've had any conversations related to, image targets on Slack, somebody at some point, I'm sure, has talked about various XRExtras components. So XRExtras is an open source library of components that we have built really to provide as a convenience to all of our developers with a lot of predefined, common needs components for not just image targets, but for WebAR experiences in general. So XRExtras provides things like loading screens, almost there screens. There's a stats module. There are media recorder modules and widgets like the capture button and a capture preview. Again, so you don't have to reinvent the wheel and write all these things from scratch. And most importantly, and relevant to today's webinar, there are many different, A-frame primitives and components, and a lot of them are image target related. And we're going to talk about some specifics, and we'll demo some of these as well and show you how they work. And how you could modify them if you want to have something work differently. So again, the beauty of this is use them as is, but because this is also on GitHub, look at the code, check out the URL listed on the screen here. If for nothing else, go there to understand just how these components are working under the covers and what they do. But also really use it as a starting point for further customization. So if it doesn't do exactly what you want, copy the code, modify it, and come up with something custom that meets your specific needs here. Okay. So some of the primitives and components that are related to our topic here today, the most common one is one you've probably seen called XRExtras named image target. So this does exactly that. So you pass it the name of an image target as you've defined it, as you've uploaded it to your 8th Wall project. So if it's called target 1, you would pass that same string as the name parameter. If it's called, Tony poster, you would pass along that parameter. And we'll take a look at this in a minute, but this basically, at a high level, when the image target is found, it makes your entity visible, and it sets the position, rotation, and scale accordingly. When your image target is updated, it updates the position, rotation, and scale. And when the image target is lost, it makes the content no longer visible. Now, this is really great to have as kind of like a container or a parent entity. And we'll talk about parent-child relationships in a bit, but by having entities underneath this XRExtras named image target primitive, they can then inherit the transforms of the image target. So if it's like, well, I want to have a video and a 3D model, I could have a video and a 3D model both as children. They can both track the same image target, but maybe I want to have them like one position to the left and one position to the right, so they both show at the same time. They both go on, they both go off at the same time. So that's that. XRExtras target video fade. So we get lots of questions about image targets and video, and well, what if there's audio or not, and autoplay. So these components are really helpful, and they handle these situations. So, I know Rigel talked about videos in a previous live learning session, and kind of all the gotchas with sound and autoplay, and how you generally have to have the user tap to play a video that has sound in it, things like that. So the XRExtras target video fade component, what this one does, and this is specifically for videos that are muted, so no sound, but this will when an image target is detected, it will automatically fade the video in, so it kind of makes it look like the image target is coming to life, and it automatically begins playback. So this XRExtras target video fade is often a child entity of the XRExtras named image target entity. And you pass it the ID of the video, and optionally you can pass in some height width information if you want to adjust things relative. Maybe you want to make it twice as wide as the image target or half as tall. You can specify these values optionally as well. Okay. Now, sound, video, image targets, these come up daily around 8th wall. So the XRExtras target video sound component is really going to be your friend. This one, because browsers require a user gesture such as a tap in order to play a video that does have sound, the way that this component works by default is it displays, when the image target is found, instead of doing something automatic with the video, it actually displays a thumbnail. So you can supply a thumbnail image that will be displayed. And it's displayed waiting for a user to tap on that thumbnail. And by doing that, you're encouraging the user to tap on the screen, you're capturing your user gesture, and now the video can play on top of the image target and play with sound. So here you would pass the video, a thumbnail of the image. If you want it to overlay, oftentimes you might take the first frame of the video and take an image of that and overlay like a little play button indicator, and that oftentimes can make a great thumbnail, so that it's really obvious to a user that like when the image target is found, you don't need to use UI elements. You just have this image with a play icon, and people know to tap on that to begin playback of your augmented video here. Okay, let's see what else. So those are probably the 3 most common image target related XRExtras components. Again, you can view the full set of components, go to this URL. It's under XRExtras source, and then A-frame, you'll see an XR components and an XR primitives.js files. And then that's a really great place to learn more and to see what is actually happening under the covers, and especially if you want to customize and build your own. Okay, so next we're going to talk about nesting components. So this is really, really useful for situations where you want to, position, rotate, you want to just manipulate or have your content be not exactly on the image target itself. Again, I'll go back to a business card example where, maybe I want to have a augmented business card where a video plays over the business card, but maybe I want to have 3D models that are offset, right? So in that case, you could have your named image target component. You could have a video as a child perhaps without a positional offset. And then you have a 3D model as another child with an offset so that it's over to the side. So here we have an example of that. You can see a little code snippet here where I have this XRExtras named image target. This is tracking my image called model-target. And then underneath it, we have this animated model, and I've moved it down a little bit. So it's going to be slightly below the image target. Just for illustrative purposes, we're rotating it a little bit. So the image target will be right side up, but the image target or the asset will be rotated, for example. And then you can also do things like maybe you add gesture controls. You want to interact with the 3D model and allow people to rotate it or pinch scale without impacting the actual location of the image target. So nesting components is something that if you haven't done any of your projects, definitely it opens up a lot of doors and gives you a lot of flexibility here. Okay. Now also a couple more events. So the XRExtras named image target, it actually emits some events on its own. And if you look into the code, you're going to see that it emits an event called XRExtras found and XRExtras lost. So this is useful if you want to kind of, let's say, filter out the noise of all of the image target events that are coming through. If you have a child entity and you want it to know when something happens specifically to its image target parent, right? Maybe the 3D model wants to know when the model image target is activated, but it's not going to care if the other image target that is spawning a video gets triggered, right? So these events are actually emitted by the XRExtras named image target entity in the scene, right? So this is really useful. Again, if you have a child entity and you want to trigger something based on when an image target event takes place on its parent. And I have just a sample code where you, like, this is an A-frame example where I'm saying this.el, so that's this element, and then you get the parent node and you add an event listener. And, as an example, maybe I want to trigger, I don't want to have the animation playing on my 3D model the whole time, but when the relevant image target on its parent entity gets found, then I want to start the playback of the animation. So, I could have my function that called play my animation that, adds the animation mixer component to the 3D model and starts playing a certain animation clip. If you look at some of our sample projects like the hologram, the MRCS image target combined example, it uses this technique as well. So definitely check that out. Okay. Now, changing active image targets. So I mentioned some of this before, but this is where the configure API comes into play. And again, you can auto load up to 5 image targets. So if you want to have 10 to start, then you would, have a call in your code that calls configure, and you would pass it along that list of your 10 image targets. The Magic Photos project in our project library uses this technique as well. This is also really helpful if, maybe you have different products, maybe product packaging, and they have QR codes on the boxes, or maybe you have different, posters, different pages in a magazine or a comic book. You might have a scenario where you have way too many image targets, and you need some type of logic to determine, well, which subset do I want to activate? So for example, you can use URL parameters where maybe you have a product viewer, on I have 10 different packages, they have 10 different labels. It's all a similar AR experience, but I want to activate the right image target so that the right box scans. So with a simple URL parameter, you could specify like product equals 1 or product equals 2. That in turn, when the page loads, you can parse the URL parameter. That would figure out, oh, well, product number 1, now I want to activate image target number 1, or product number 2, I want to activate image target number 2. So you can use that type of simple logic to activate the specific image target that you're interested in here. Okay. Really, when you call this or how you call this, again, this is one of those scenarios where you can implement your own custom game logic. So, maybe you have a book and, users are going to read through the book from start to finish. Well, let's say it's a 500-page book. I can't activate 500 image targets at once. I can only activate the first 10. So you can do tricks like, well, when they, get to, activate pages 1 through 10, and then when they get to page 10 and activate that image target, that can be the trigger to then activate, image targets 11 through 20, right? Or then when they get to 20, it can activate 21 through 30. So you can have different events that take place, whether it's or it could be a button press. You could have a UI element, a UI menu, where the user selects, which page in the comic book they're on. And if they select page, 71, well, then that activates and loads the appropriate image target for that page. That could be a good strategy if you have a large number of image targets, or a large book or a large magazine where you really don't know what order they might be viewing things in. So I've seen a lot of people call this too soon. They call it right at the beginning, maybe even before the XR8 library has loaded. So just to save you some time and some frustration, make sure you wait for the XR loaded event before calling configure. So you don't get an error, or it doesn't work sometimes but not others. So that's some tips with changing image targets here. Okay, so with that, let me switch gears, and I'm going to jump into a live demo and show you some of these components here. So I'm going to bring up my phone. I'm going to bring up, oops, wrong screen here. We're going to bring up the cloud editor. And what I've done is I've based this off of the Jellyfish Flyer project. So let me pull that up. Again, if you go to our project library here, lots of great starting points, whether it's curved image targets or image targets plus SLAM. Here is both image target and SLAM, but for flat image targets. The endless image targets component is the one I was mentioning, where there's like 20 different pictures of birds, and once you scan the 10th one, then it activates the next set. In today's demo here, we're actually going to be starting with the A-frame target flyer example, and we're going to make some customizations and build upon this as a starting point. But at a high level, this project has 2 image targets. There's the top left image that by default spawns a 3D model. We have an image at the bottom right that overlays a video, and we're going to go through and do some things here. So in this example, it's a muted video. We'll talk about sound. We'll talk about switching it to fading in. So let's do that. So first things first, I've got my phone over here. I've loaded the page. Let's reload here, access camera permissions. And I have the flyer here as part of an asset, so we can just scan this on my laptop here. So this is pretty straightforward. I've found the first image target, and this one's called model target. And then I have a 3D model, and I have a gesture detector where I can do a 1-finger swipe, and I can rotate it pretty easily. And then down below, we have the image target called video target, and this is actually playing some sound here. You probably can't hear it through the Zoom, but this has a thumbnail and this has a tap to play mechanism here. So let's take a look at what's going on. So here I've got my body.html. I have a couple of assets. I've got my video asset. So this is the video with sound. You'll notice that there is no autoplay attribute on this. There's no muted attribute. So this is my video that does have sound. I have another copy of the video without the sound, and we can just swap this out in a little bit and show you like the fade in and how that works. Okay, so then down below, I've got my 2 XRExtras named image target components, and let me actually zoom in and make this a little bit bigger. There we go. Okay, so I have first in my scene, I have XRExtras named image target, and I've passed it the name video target. So if I go to my image target screen here, I have these 2 image targets. Again, video target, model target, pretty straightforward. Let's go back to the code editor here. And this one is going to fire when it finds the image target called video target. And as a child of that, I have this XRExtras target video sound. So this is the component that is not going to autoplay because the video has sound. It's going to display my thumbnail. And the ID is this jelly thumbnail, and that's an image that I have up here in my asset. And the video is this jelly video, which is the ID of my video tag. And then I've got a height and a width, and we can go from there. Now, maybe I want to change some things around. So this is that benefit of having a child entity where perhaps I want to offset some things. So let's, here I have the model target, and you'll see how it's exactly aligned with this, and it's playing now. So let's change it. I'm going to set an offset. So let's go in here and let's say position, and we'll move it over to the, let's move it to the right a little bit. And rotation, let's do a rotation of 0.5 perhaps, and let's make it like twice as wide. So again, the image target itself isn't changing, but I can now scale things relative to the image target. So, this is nice where if you want to, let's say, position a 3D model at a fixed size, you can say, well, if I know the width of my image target, now I can scale my 3D model in relation to this known fixed image target size. So let me do a save and build here. And once that's done, my phone is going to reload. There we go, grant camera permissions again. Let's bring up the flyer, and if I did things right, now I've got my video, and you'll see it's like shifted to the right, it's rotated 45 degrees, it's stretched wide, it's twice as wide as before, and it still can tap to play. So, not the best real world example here, but this just illustrates the point that, again, if you want to have your content like placed relative to the image target like this, there's a very easy way to do that using parent and child relationships and offsets here. So here, again, I scaled it, I moved it, and I rotated it. So let's get rid of these just for a minute. We can leave let's leave the scale. And now let's switch it out. So this one is using the target video sound. So now I want to do the target video fade. Okay, and I'm going to swap this out. We're going to, use the video that doesn't have sound. So you'll notice here that I've got autoplay on my video tag. I've got muted, and let's save and build this. Let's try it again. So while this is rebuilding, I'm going to go ahead and bring back up my flyer. And here we go. So now point this at the video, and you'll see here that it's going to fade in, and it's fading in. It's twice as wide because I set width equals 2, but it faded in gracefully, and it auto-played here, which is really good. Okay, so now maybe and when the image target is lost, it fades away. So now let's talk about creating custom image target components that are responding to image target event listeners. So what I did is I started by going to GitHub, as I mentioned previously, and I grabbed the XRExtras component for the named image target. So if you scroll all the way to the bottom, you can see these different components. We have named image target. So we have XRExtras named image target, and that's this named image target component. So if you look here, you can see all the code where this is doing some things with generating geometry, and it's got different listeners. So it has an XR image scanning listener, found, updated, and lost. So I've copied all of this code and brought it into my cloud editor project, and we're going to modify it. So this one I've called my named image target component, and I made a few modifications. For right now, we're not generating the geometry. I just have a console log statement, so I know what it initializes. This is basically has a show function, has an update function that's setting the position, rotation, and scale, setting it to visible true. Show image is basically just calling update image. And then in the hide function, it's making it setting visible to false. So it will hide it. But maybe I want a situation where once the image target is found and my content spawned, if somebody loses the image target, I don't want that to go away. So we'll modify that in just a minute. But first, let's go ahead and import this. So I'm basically going to import these components from my JavaScript file. I'm going to register my component. It's going to be called my XRExtras named image target. And then we're also going to register a primitive. So I can either use this as a component or I can use this as a primitive. So let's do that. And let's apply that to the model target. So we're just going to call this one my. You can call it whatever you like. And if I don't have any syntax errors, this should all just work. And let me go ahead and save and build. So now instead of pulling the one that came default from XRExtras, we're pulling this one that I've made some slight modifications. And we haven't done much just yet, other than add a couple of like console log statements. And you can see here, yep, it's actually using it. This is a great way to make sure that it's using your component and not the one from XRExtras. So it's initializing it, and when I find the model target, you'll see here on the screen, it actually it had a console log statement that it found it, but when I find the video that's using the built-in one, it's not going to fire any of those events because that's using the XRExtras version, not my custom version here. Okay, So now let's do this. So I don't want the 3D model to disappear when I lose the image target, right? So you could either, comment this out or do something differently inside here. Like you might want to have it snapped in front of the camera. You might want to have a timer where if the image target is lost, maybe it gradually fades away. It doesn't turn off immediately. But in this case, let's just have it not do anything if the image target is lost. So I'm going to just comment out this line that is listening for the lost image target event. So now once this rebuilds, what we're going to see is a situation where while the image target is in view, while the image target is in view, it's tracking, right? So here we go, it's tracking it, I can interact with it, but if I lose the image target, well, now it stays on screen. So, this is something that some experiences want to implement where, if the image target goes away, the most important thing is I want to use it as a trigger, not so much an anchor. This is one way to kind of do it as both, where the image target can be both a trigger and an anchor. But if the image target is lost, you're not losing any of your scene content. So here I can still interact with this. And that will just sit right there. And it's not going to do anything because I don't have any code that will ever tell it to hide this. Okay, so now let's make a couple of other changes in here. Let's switch it from the jellyfish to a different 3D model. So we're going to switch this to like the robot 3D model. And let's see what happens when I make that change. Now, 3D models can be built differently. The pivot points and the transform might be in different places, like in the jellyfish, it's at the center. But at maybe a 3D model of a car or a robot, it might be at the very bottom, and things might not align exactly as you want. So again, let's go ahead and do this. And now I've got my 3D model, and this isn't exactly the experience that I want. It's like too high. I want this to be over the image target, not mostly above it. So this is another case where having an offset is going to work. So let's go down here, and I want to do a couple of things. So I want to set a position equals, let's do, how about 0, -1, 0. And I don't want to have a gesture control. Maybe let's have this 3D model just spin. So one of the other many XRExtras components is one called XRExtras -spin. We could also scale it if we want, scale, and let's make it like half the size. So, an easy way without having to deal with like the math related to the image targets or rebuilding your 3D model by having this as a child entity on my custom image target component, I can now just manipulate this exactly as I want. So again, let's go ahead and bring this up. It's reloading the page. And here we go. So I've got my image target, and now it's lower. It looks like I moved it a little too low. But it is tracking the image target, and it's spinning instead of having gesture controls. And if I lose the image target, it's just going to stay in place and it's going to continue to spin. So again, here I've got, I'm defining what events I want my component to care about. In this case, it's just found and updated. And here you can see exactly what it's doing. It's basically tracking the image target, but this is also where, in your show function, this is where you could be like, okay, show a UI element or, trigger animation of my 3D model or things like that. So the sky is really the limit here, and knowing and understanding the building blocks of the events that fire related to image targets and how you can, create entities and how they relate to another, you can pretty much, implement whatever you like here.